Most engineers calculate beam shear reinforcement, but here is the twist. See, if torsion is present, your design might still fail. Look, designing beam is all about resisting bending and shear forces. We check loads, moment and shear. Everything seems fine on paper, but IS 456-2000 has a small but very powerful clause that many beginners overlook, and it changes your stirrup spacing completely. Look, here is the problem. When torsion comes into picture, even a tiny amount, the rules for stirrup spacing become stricter. See, most engineers stop after checking shear spacing requirements, but clause 26.5.1.7 adds an extra check, and if you skip it, your beam may not meet code compliance. So let's understand this through this clause from IS 456. See, it says that when a member is designed for torsion, the transverse reinforcement for torsion shall be the closed rectangular stirrups placed perpendicular to the member axis, and this spacing shall not exceed the least of following three equations. You can check these three equations over here: x1 plus y1 divided by 4 and 300 mm, where x1 is the short dimension of the stirrup, from y1 is the long dimension of the stirrup. So let's understand this through an example with a beam size of 300 mm wide and 600 mm depth with a clear cover of 65 mm, and let's assume the stirrup of 8 mm. Okay, so we can calculate this. You can check out this calculation over here based on this x1 and y1, right? 178 and 478 is the answer that we get, and for the ratio we are getting 164 mm. So the least of all of three, that is 178, 164 and 300 mm, the least is 164 mm. That means even if your shear design allows 250 mm spacing, torsion limits it to 164 mm maximum. And this is why in STAAD or other design software, you sometimes see spacing much less than your manual shear calculations, because torsion spacing is governing. So even a very small torsion moment can trigger this check. So here is the lesson. See, when torsion is present, always check this particular clause 26.5.1.7 in addition to shear. This could mean using more stirrups than you initially expected, but it ensures both code compliances and structural safety. So would you have caught this torsion spacing limit in your design? Comment below and don't forget to save this video. You'll thank you yourself during your next project. I'll see you in the next video. Till then, remember, don't just learn software, learn concepts.